Texan Global School. We will analyze decimal numbers and their transformation to fractions in this class. Let us remember that the rational numbers are all those numbers that can be represented in the form p divided by q as a fraction. In this way, we will analyze decimals that belong to this subset. In previous classes, we saw the parts of a division and their various notations, as we can see. It is essential to become familiar with mathematical terminology for problem solving. In decimal numbers, the position used by the decimal point serves to separate place values less than 1 from those that are greater than or equal to 1. Each place value is 1/10 of the value to the left. In the following table, you can see each of the positions of each digit of a number. Starting from the decimal point to the left, we have ones as the first numeral on the left. Then the tens, hundreds, thousands, tens of thousands, etc. From the decimal point to the right, we have tenths as the first numeral on the right. Then hundreds, thousands, and so on. Given a decimal number, we can find the equivalent number as a fraction. The process involves locating each numeral according to its position. Then, the numerals to the left are multiplied by multiples of 10. The numerals to the right are multiplied by multiples of a tenth. Finally, all the previous values are added, and the fraction is simplified. Let's see an example. We will obtain the equivalent fraction of the number 0.4. By placing the numerals according to their position, we can see that we have 4/10. This means that 4 multiplies a tenth. We perform the operation 4 times a tenth, obtaining 4/10. Simplifying, we get an equivalent fraction of 2/5. In the following example, we will also obtain the equivalent fraction of the number 0.384. By placing the numerals according to their position, we can see that we have 3/10, 800ths, and 4,000ths with their corresponding equivalents. Now we add those values. Performing the operation, we get 384 over 1,000. We can see that a simpler way is moving the decimal point to the right, and the remaining number 384 is divided by 1,000, 3 zeros according to the number of places the decimal point is moved. Now we simplify the fraction, obtaining 48 over 125. In the following example, we will also find the equivalent fraction of the number 12.34. From the decimal point to the left, we have 2 ones and 1/10 with their respective values. From the decimal point to the right, we have 3/10 and 400ths. Now all these values are added. The result of this operation is 1,234 over 100. As we mentioned, a faster way is to move the decimal point to the right to the last digit. The number of places the decimal point is moved is the number of zeros in the denominator. Simplifying the fraction then, we obtain 617 over 50. Now, given a fraction, we can find the equivalent decimal or integer number, depending on the case. This is done using the long division operation of the numerator by the denominator. In the following example, we will use the long division algorithm to obtain the value dividing 2 over 4. The numerator 2 is placed inside the division bracket as the dividend, and the denominator 4 as the divisor outside the division bracket. Since the dividend is less than the divisor, then we put the decimal point since we cannot perform the division. This involves writing a 0 to the dividend, thus having 20. Now 20 divided by 4 results 5. This is the quotient that is placed on top of the division bracket or long division symbol. We multiply this value by the divisor, thus obtaining 20. We subtract and obtain a remainder of 0. Therefore, 2/4 results 0.5. We can verify by transforming 0.5 into a fraction. This is 5 over 10, which simplified is 1/2 equals 2/4. In the last example, we will obtain the decimal number of a third. We repeat the process by performing long division. We can see that in this case, the 3 of the quotient is going to be repeated indefinitely. This means that 1/3 is 0.33. A dash, named vinculum, is placed above the digit 3, representing that number will continue indefinitely. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com